And welcome to CTL's Education Professional Development Series. My name is Amy Alcalisi, EdTech Project Manager here at CTL, and I'm joined by Walter Drimmer, Technology Specialist, and Stephanie Shea, Marketing Manager. Here at CTL, we've been headquartered in Portland, Oregon, providing innovative IT solutions to education and government customers for over 26 years. We're Google for Education partner specializing in rugged CTL Chromebooks, laptops, convertibles, 2-in-1s, and tablets designed specifically for K-12 education. Over the last 3 years, we've worked with Google to introduce a line of CTL Chromebooks that have been recommended by PC Magazine as the best choice for Chromebooks in education. As part of our commitment to education, CTL offers free professional development webinars on a variety of topics relevant to K-12 ed tech. Today's webinar is LabCam Motion Diagrams, presented by Ms. Viola Bodo, Sales Content Manager at Intellisense. Before we get started, I'd like to review the attendee interface so you know how to participate in today's event. You should see something that looks like this up on the right-hand corner of your computer screen. You are listening in using your computer speaker system by default. If you would prefer to join over the phone, just select telephone in the audio pane and the dial information will be displayed. You may type any questions in you may type any questions into the question pane of the control panel during the presentation, and they will be addressed in the question and answer session at the end of today's presentation. Excuse me, that's what I meant to say. Let me see here. Before I begin, I'd like to take a little poll. Let me see if we have a poll up here. We might not have one.
Hi, this is Stephanie. There is a poll about their role within their school.
Okay, yep, there it is. I see it. All righty, let me launch that out. Thank you, Stephanie. All right, hopefully everybody can see that. All right. And we do have, okay, great. We've got 75% coaches online and 25% other. Let's see if you guys can see that. Thank you for taking the time to doing that. And good morning here on our time. Amis is on the other side of the world, and it's about 6 p.m. her time. All right, let's move on. Before I turn it over to Amis for our presentation, I'd like to remind everyone about some resources for Nevada 21 educators. When you visit the nr21.ctl.net website, you can learn about upcoming professional learning opportunities. You can sign up for upcoming events, information, and join our Google Plus private community for Nevada Ready 21 educators. I would like to now introduce Ms. Viola Bodo, Sales and Content Manager for Intellisense. Ms. is an expert in LabCam software, having presented Intellisense at exhibitions and created demos for them. She brings her experience as an applied mathematician and former educator in mathematics and STEM subjects. Ms. is in charge of marketing and user support, as well as sales and social media activities. Ms. will be discussing and demonstrating LabCam's Kinematics and Graph Challenge modules, and will do experiments with everyday objects to explore different physical phenomena such as velocity, acceleration, preservation of energy, and more. That was a mouthful. All right, Ms., I'm going to switch it over to you. I know you're going to be using some of your LabCam as well. Thank you for your patience, everyone. All right, I will mute myself.
Okay, so thank you, Amy, and hello everyone. I'm Anasha, and I will start my slides. Okay, so my previous presentations were about LabCamera in general, like a demo for the software. I wanted you to get familiar with its functionality and to see what it is basically capable of. But this time we decided with the CTL team that we will do it a little bit differently. And now we will focus on one specific topic, which will be the motion diagrams. Of course, it's still quite a general theme, but it allows me to concentrate on 2 of the modules of the app. And this way there will be less theory and a little bit more practice. And hopefully I will be able to hand over a more concentrated but very, very useful information for you. So let's get started. Our aim when we developed this software was to create an actual teaching tool helping your teachers work in science education. LabCamera is like a science laboratory, but you don't actually need a super expensive lab, but you will be able to create experiments which are laboratory-like. You will see some examples about this. You can see this 10 to 15% highlighted here, and I did that because it's a really good result that we got from a study that the biggest Hungarian science university created for us. They carried out this study in which children use LabCamera for homework only. And still, they did pretty well because their results were about 10 to 15% better compared to those kids who followed the traditional methods. So we are very proud of this, and this is why I pointed this out. So here are the 7 modules that we have in LabCamera. So we have time-lapse and kinematics. Kinematics is for motion tracking, and then there is the motion cam, which is a motion sensor camera. This purple one is called microscope. This is my personal favorite, and if I remember correctly, it will be part of the next session in March sometime, so I'm already promoting that one. Yes, going on to the next one, this is called Universal Logger, and this is for data logging, logically. Then we have a Pathfinder module with which you can draw motion density maps. And then this last one is the graph challenge. So we will focus on the kinematics and the graph challenge module this time. So the kinematics module. It's mostly for physics teaching. You can track objects and then analyze their motion. The software is capable of following up to 3 objects, which allows complex kinematic experiments. So, for example, what you can see here is some kind of pendulum experiment where there are 3 masses here, and of course it's logical that you would want to follow all of the 3 because the point is to compare their motion and to see what they do together. So it's really practical, and in the live experiments that I'm going to do after the slideshow, it will be essential too. So so the kinematics module can draw displacement, velocity, and acceleration diagrams, which will be on the right side of the screen during the experiment. But of course, you can save these data and analyze it. So this kind of images can be saved. Yes, and after this slideshow, I'm going to show a couple of examples. How this can be built into an actual lesson in school, because this is what teachers always ask me. Okay, this is brilliant, but how do I use this in my lesson? And yes, this is what I will try to answer here today. And the other module, the graph challenge module that I'm going to present here is a game-like module. So it's with this module, children can learn through playing and having fun. So they don't even know that they are learning, but still they can benefit a lot from this fun. The point of this game is that you have to, so the task is that you have to follow the shape of a curve with a selected object. So here there is this sine curve, and with this ball you will have to follow its shape. And this is in connection with the kinematics module, because in the kinematics module you can see some motion, and then the software produces the graph. And this graph challenge module is the other way around, because you can see the curve and you have to produce that motion. So it's in connection with that one. Okay, this next slide is to sum up the main strengths of LabCamera. So it covers several science subjects because of its complex functionality, and maybe even more importantly, it develops higher order skills like collaboration, problem solving, and drawing conclusion. These are very, very important skills. And this is because most of the experiments can be made in groups of 3, groups of 4, usually. So kids have to set up everything together, and then they can discuss what they experience and what they observe. And yes, one more important thing, that these experiments are in connection with computers. Very, very important, because kids just love playing with modern digital tools. So whatever is in connection with computers is just so much better than learning from books. So this is something with which you can make children more engaged to science and learning. Okay, I show this slide to you about the resources and our resources side, because the experiments that I'm going to do are all from this site. So on intelligence.education, you can find many lesson plans which can give you ideas and sample videos, sample images for the lessons. So later I will show you what these lesson plans look like. So please check out this site. Okay, besides the resources portal, we have a YouTube channel, a blog, Facebook and Twitter page. All of these are meant to help and support your work. So please check them out as well. And the very last thing I would like to show you through these slides is some numbers. So we have more than 9 million sold licenses out there worldwide, and we are very proud of this number. Then there is this 15% higher exam results that I mentioned, and here this slide states that 100 plus lesson plans. Well, right now we have about 150 uploaded, and with my contents team, we are continuously creating new ones. The LabCamera app is available in 29 languages. You will probably use the English version, of course, but maybe a Spanish or French version can be interesting for you too. So it's just a possibility. And now I think I will stop showing my screen, because this was the slides part. And now comes the fun part, where I actually can show experiments. So I stop screen sharing and turn on my camera. Okay, so I'm going to use this laptop and this external camera and some everyday objects like balls and this something, I don't know what's that called. And then there is a pendulum and a couple of other things. So this is the LabCamera that you can see. The colors are not too good, but anyway, the point is that this is the LabCamera, and and I just start the kinematics module because this is what I promised you what we will do today. So here is LabCamera, and the first experiment is going to be about these balls and the trail. So I just set the camera. So what you can see here is that we have 4 balls, and they are different colors. They have different colors. And the experiment, I just show you quickly what is the experiment. I will grab the yellow one, put it to the side. I will toss it a little bit and see that the orange one will move as the yellow one stopped. So the phenomena here is momentum conservation, and we have a lesson plan for that. It's called Colliding Balls, and it's available on our website. And I just would like to read out the beginning of this lesson plan because it states the core topic of the lesson plan. So it says, energy is present whenever there are moving objects, sound, light, or heat. When objects collide, energy can be transferred from one object to another, thereby changing their motion. In such collisions, some energy is typically also transferred to the surrounding air. As a result, the air gets heated and sound is produced. So as you saw, my experiment, this exactly covered this core topic that I just read out. So this core description is actually from I think it's from the New York University, the New York State Core Science something. So it's from the core curriculum, and this experiment is going to help you demonstrate the phenomena very easily. So here what I can do is to calibrate. So on the side I have to select calibration, and I can select the size of this ball because I know that this is 3 centimeters, so it's 3 centimeters, and now the measurements will be in centimeters, and by clicking on any of the objects they get selected. So now it's the yellow and the red ball that is selected. I just have to put back the yellow one where I want this to be. Okay, and the orange one too. Okay, and now if I record, I will be able to analyze it later. So now I start recording and I do the experiment. So I toss the yellow one. Okay, and the red one is gone. Okay, so this is what I recorded. Of course, this not so nice part is when the red ball disappeared. So let's just forget about that and concentrate on the nice part. So what you can see here that neither of them is moving. So there are straight lines. And then the yellow one started to move. At this point, the yellow one reached the blue balls, and then the red one started to move. And as you can see, their velocity is not the same. How do I know that this is velocity that I'm talking about? Well, actually, you can read the time and the displacement here. So the first task for children can be what was the velocity of the red one, what was the velocity of the yellow one, and then we can talk about.
Excuse me, this is Amy. We have a few people questioning they can't see the screen or the share settings. They can't see your experiment.
Oh,
so let me see. Yeah, they can just see. I screen shared it to you, so let's do a little bit.
This is Stephanie. I'm definitely seeing it, and it popped up in a smaller window that I opened up bigger, but it is part it was part of what I was seeing, and now I have it big on my screen. So I wonder
Yeah,
if
we can
anyone's
see it.
browser got on top of it.
So yeah, check behind the browser people or behind your screens to see if that works. Because we had this last time, if I remember.
Let's see what people are
Because I
saying.
had Nate mentioned it to me, and he showed me a picture of what he sees on his screen versus as a panelist.
And Chris says he can see it and that it could be buried under other
Okay,
windows.
look under Windows, and then if you got, yeah, please put it in the question box or text me if you have my text. All right, Amise, thank you so much. It looks like we just have one person that is having trouble seeing that, so just sorry for interrupting. Keep going.
Sorry,
Okay.
Nate. We can always show you the recording. I don't know how that's happening.
Okay, so then maybe I do this experiment once more because it's just a few seconds to
No, it'll
repeat.
be on the recording.
Oh, okay. So then I just show the result of the experiment. So what happened is that the yellow one was not moving, and then it started to move with a certain velocity that can be easily calculated from the collected data. And then when it stopped moving, then the red one started to move, but with a different velocity that can also be calculated. So, so here, these are small and pretty easy tasks for children, but still they calculate from real collected data what they themselves could collect. So it's a really exciting task for them. They can work in groups. They can do this as a home project or something like that. And when I read the core description, I talked about some energy loss, and actually when you do the experiment in the class, then you can refer to that sound what children could actually hear. That yes, there was the sound which was mentioned in the book. So it's really lively experience for them. Okay, so this is the first experiment that I wanted to show you, and I have another one which I will only show through a video, because on our website you can also download links, so download videos. So for every lesson plan there is a video link or an image link where you can download the video. So here the experiment is this. I just played the video. So this is a little ladybug toy which is hanging on a spring, and this is the experiment. Just this little toy hanging on a spring, and the question here is what is the connection between the period and the mass of this toy? And for this, we have different videos. We have this video, and there are two more where there is some extra mass added to this toy, and then you can make several experiments, so actually 3 of them, and then you can compare the data. So let's do that. I can select by clicking on the red dot in the middle, and of course now I have to select the y-axis because I want to observe the y-axis kind of movement. So now I selected the y, and I can just start recording and play the video again. And on the side you can see the displacement graph. change the scale. So this is the experiment. You can see it's very nice harmonic motion. And when it is ready, I can open the collected data. So this is the x-axis. We are not really interested in that, but this is the y-axis. And what you can do is you can calculate what is the period time. So for example, you can calculate how much time it took to make 10 oscillations. And then if you calculate, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is it. You can see it started around 4.9 seconds and it ended around 30.5 or something like that. And then you can calculate what was the average period time for this one. And then you go back and load the other video where, oh, this is not what I wanted. Yes, so you can load the other video, the next one. You can see here is a little bit of added mass and do the exact same experiment again. But yes, this is not the exact same experiment, but it is a little bit different from that. So now you can see the graph again, which is very, very similar, but this is what we want to observe, if it's the same or not the same. Before making the experiments, you can discuss with children if what they think. Does it so does it depend? Does the period depend on the mass? If yes, then is it so the bigger the mass, the bigger the period, or how is this? And now from this one, you can also calculate the average period time, and then do the next experiment with the third video and calculate the average period time there, and then you can see what is the result. And actually, children themselves can draw the conclusion, because it's really logical, and they can figure out what is behind this experiment. And actually, this is what oops. So this is what a lesson plan looks like. So there is a short summary. There are objectives, recommendation for use in class, and some tasks. And I will show you the end result, because there is documentation about it. So this is the end result. Here are the 3 measurements. So with the different masses, the different periods, and as you can see, the bigger the mass, the bigger the period becomes. And this is something that children can draw these points according to their measurements and calculations, and they can draw the conclusion themselves, which is, I think, a very, very important thing in case of the learning process. So this was the second experiment, and as I mentioned, the 3 videos are available when you look for this experiment. This one is called Dependence of Period and Mass of a Toy on a Spring. So we have different versions of this anyway. So there are basic and standard levels of this with more tasks and more things to measure. So I think this was what I wanted to show you about the kinematics module, and now I would like to show you the graph challenge module, so which is the other way around. So when you have to start from the graph and produce the motion. So I'm going to use this camera like this, and here what I have to do is to grab an object like this ball, for example, and if I click on this object, it will be selected. I don't know if you can see that. Yes, so this ball is now selected, and what you can do is to choose one of the curves from here. So like, for example, the cosine function. And if I choose up and down, if I move the ball up and down, you can see this dot moving up and down. And my task is, if I start the game, I will have to follow the curve. So now, if I know that the direction is up and down and time goes from left to right, I will have to follow it. 82%. I'm not not too good at this task, but anyway. So here, from this point, I know that this cosine kind of movement was like this. So I experienced it. I felt it, that this motion produces that graph. And of course, you can choose a different graph, or you can go wider and say that I want to do left and right. So now this is the top, and this is the bottom. And now this is the task. I have to follow the graph like this. It's much more complicated because the curve goes up and down. And if I do the up and down version, then it's not that hard. But if I have to go left and right, but the curve goes up and down, then it's just super complicated, and children can have so much fun with this. And if that's not enough, you can go further closer. So now this is the top, and this is the bottom of the curve. So let's see that one too. So this is the top, and I have to go closer and come back. Ah, okay, that was almost 100%. So this is the graph challenge module, and we have different curves. So there is a cosine, but here is a sine function as well. There are like this jumpy function or jumpy curve that is a little bit more different from the previous ones. It can be more fun for children. Also, you can create your own curve. So this is it. You can add some extra points and position them how you want. So like this. And then this is your new curve. You can make it a little bit smoother. You can change the duration and then make it, for example, now it's 10 seconds of the game, and then you save. This can be the MSH curve. And now we can play with this one. So now let's select the ball again, choose up and down, and see what motion I will do if I follow this curve. Oh, okay, if I can follow this curve. Yeah, this is a longer one because it's 20 seconds. Also, it can be an interesting task that children can do some kind of movement and figure out what that movement looks like in a graph. So they have to draw the graph and then see if that motion is really what they wanted it to be. So this is the graph challenge module. This is like a game, but it's a good like extension for the kinematics module. So yes, I think this is what I wanted to tell you today. So if there are some questions, I'm very happy to answer them. And I think I turn off the camera now because we don't need that anymore.
Great. Walter here, and we do have some questions. one of the questions, I think you answered it, but am I coming through? I'm hoping. Um, is is that you can create videos yourself and then use the videos versus going live to be your experiment. Was that true?
Yes, yes. So you can create a video and then load it to the application, which is very useful if, for example, you want to record something outside, like you want to record some cars, and then you cannot do that in, like, the live version.
Yeah, and
Can you show your screen? Because right now it just shows the blank white screen. So if you need to flip through your slides.
Yeah, sure, sure. Yes. Now I think
Yeah,
you can
thank
see
you.
my.
great. Thanks, Amy. Another question came up is um, you mentioned a group of students can do this, and I think you mentioned it. What's the best size, and then what's the maximum size you've seen people use the experiments with?
Well, actually, I think it's possible to do the experiments even alone. So if everyone wants to work by themselves, then it can work too. So I think the minimum is one, but I prefer if at least two or three children work together, because it's just better that someone can set the camera, someone can select the objects to follow and things like that. And the maximum is somewhere around 5 or 6, because if there are too many children around one computer, then it can become a crowd,
Okay.
and that's just not practical anymore.
No, that's good. Another question came is when I track objects, do I have to use different colors, or can I use, I guess where can I use different colors versus just one color?
Well, if you want to do, for example, a collision experiment, then you have to use two different colors, because the software recognizes colors, and if they are of the same color, and when they touch, they will become one big red something, for example. So it's practical to use different colors, but if they don't touch, then they can be of the same color.
Is is if you have two, an orange and a red, it'll discern between the uh, if you have close reds, they'll still discern the different color of reds.
Well, actually, you can use an orange and a red, and yes, if the lights are good, and if it's so if they are really different colors, then they will not meld into one. But if they are really close to each other, then I would say let's just use a blue one or something.
Okay, so they need different color ones. The other one was the maximum speed for tracking. Is there a maximum speed?
Well, actually, it depends on your camera what you use, because you can do, for example, a free fall experiment, and then in case of a free fall, the objects can move very fast. But if you work with a good camera, then that's perfectly okay.
Awesome. The other one is I haven't looked at the different videos that maybe the students have done, but somebody had a question if the students want to document this into a video and make it an experience, what's the best way you found to do that?
I'm not sure if I understand what you just asked.
I think what they're wanting to do is document the experiment. Um, and I guess it the best way, like I mean, does the graph that's being run get recorded so that you can play it back? Um,
Um,
it's more, I guess the simple part of that question is they just want to document their experiment.
Yes, actually, if they record the video, then they can save all the data that they create, and then they will have the documentation in pictures plus their own video, and then I think from that they can put together a nice documentation of a project.
Okay. And is there examples in the resource like that, or kids doing ones?
Actually, in the resources site, there is always, so in case of a lesson plan, there is always a recommendation for use in class, which is for the teacher to know how to use the lesson plan and how to integrate the experiment. And then at the end of the lesson plan, there is a document body where you can see some images and of course the downloadable video is also there. So I think yes, it's all provided.
Awesome. The last question was, can I export the data that I record?
Yes. So for children, I think the most important is that they can save it as an image, so the graph can be saved in an image format, but also it can be exported into CSV format. And so if someone wants to do some more serious calculations and needs the exact data, not just one from from the picture, but exact numbers, then it can be exported to like an Excel sheet or something.
Great. That's the questions I have, Amy. So I think we're good there. See if Amy.
Yeah, no, Amis, this is great. And just for everyone to know that there is a part one and a part two that already has been recorded. This is recorded as well. So it's very exciting. This is different and it's really simple to use. It doesn't take any extra devices or anything like that. And you guys already have the app. It's part of the NR21 program. So definitely email and ask any questions you need. And so I think, Amis, I will switch over to my closing screen if that is all that you
Okay, and
need.
I stop screen sharing.
Yeah, thank you so much. It it was very helpful, and sorry about the confusion there, but I think that might have happened last time. Sometimes people forget it's like hiding, or they can't completely see it. So, all right. Well, I just want to thank you, Amis, and thank you everyone for attending today's webinar, LabCam Motion Diagrams. So if you have any questions, contact us at the email you see on the screen. And once you leave today's webinar, you will receive a certificate of completion by visiting the link that you see on the screen. And if you wouldn't mind filling out the little survey, that will help us gauge our effectiveness to these webinars and improve how we need to improve and give us your feedback. So please don't forget to visit our nr21.ctl.net website for news and information. And again, the link of the recording of today's webinar will be sent out within 24 to 48 hours. And you can find part one and part two as well, like I said before. So on behalf of CTL and our presenter and all of you guys joining us, thank you for joining us today and have a great day.
Thank you.
Bye.
Bye.